So in the spirit of Christmas and turning on and off lights, let me show you how you can take this simple FET and turn it into something pretty cool. And by something pretty cool, I mean how to control a Christmas tree like this one. A lot of these trees come with LEDs. These might look like incandescents, but they're actually LEDs inside, which turn on different polarities of the LED. And what I mean by different polarities is that inside of that LED, what's actually going on is this. You have an LED pointing this way and another LED pointing this way. So if you change the polarity here for plus to minus or minus and plus, you drive at least one of them. For example, this top one could be a color LED and this one could be a steady white LED. So depending on how you put the voltage is the one that will turn on. And before I show you the simple circuit, there's one more thing that you need to keep in mind. When you pick this FET must be rated for the total voltage of your whole entire branch. By branch, I mean the total amount of LEDs that you have hooked up in series. And a simple way to calculate the total voltage of the branch that it will be required for it to turn on, just assign a regular value of 3 volts per LED. So if you have 3 volts here, that means that you need 6 volts, 9 volts, and so on. Alright, so now that you know how to pick your FET, the next part is pretty easy. You just put your branch here with the positive on the top side. And let's call this V, because this could be as many LEDs as you want, as long as you pick this one correctly. And now you connect it to the drain of the FET, and the source goes connected directly to ground. And now the gate can actually go connected to something else. Now, if you're going to work with FETs, you can add a button here, but you should add a resistor here to ground. If not, when you turn this on, it probably won't turn off immediately. It'll actually stay floating because there's a small capacitor here that stays charged, and it takes a long time to discharge if it doesn't have a path to ground. This is technically the whole complete switch. You can also add a microcontroller here like an Arduino to turn it on and off. And if you stay this long, this means that you're implementing it. So I'm going to show you how to keep this very safe. If you just power an LED like this, you could technically burn it if you don't calculate the drop voltage correctly. So you need a current limiting resistor. And if you use Ohm's law, which V equals IR, and I stands for current, let's limit the current to be only, let's say, 20 milliamps. So if I have 20 milliamps and I have a voltage of, let's say, my whole branch voltage, let's say it equals to 30 volts. Now I can just solve for R, and then this is resistance. You're going to put it here in series. Now you have to be sure that this resistance can handle the current rating or the power rating that you're going to put through it. However, if you don't want to deal with any of that resistance, if your LED is 3 volts, just use 2 volts. And you will never reach the full current capacity of the LED, and you should be fine. You would just need this component. If you guys have any questions, this is a long one, so leave me a comment.